Hi, and welcome to the video on section 5.2, power functions and polynomial functions. Our learning objectives for this section are to identify power functions in behavior of power functions, polynomial functions, and some characteristics of polynomial functions, degree, leading coefficient, etc. All right, but before we really jump into that, we're going to take a minute to just review four important toolbox functions. And actually, it's really two toolbox functions, but I said four because there's four graphs. The first one that I want to talk about is f of x equals x squared. So here in the left-hand side here, this is our graph of f of x equals x squared. It's a quadratic. It's point opening up because the leading coefficient is positive, and that's what x squared looks like. You should be able to memorize this and know what x squared looks like in your head, and if you do, this whole section is going to be a lot easier. In green here is minus x squared. F of x equals minus x squared. Looks a lot like x squared, except for it's facing down, right? So when we look at these two functions, one thing I want to think about is what is the end behavior, or sometimes it's called long run behavior for each of these functions. And what does that mean? It means that if, for example, let's look at x squared. If we let x get really, okay, I need a pen to write with here. That's going to be helpful. If we let x get really big, so as x gets big, x moves this way, getting bigger and bigger and bigger. In fact, even as x goes to infinity, what happens to the function? Well, x at 0 is 0, at 2 it's 4, at 4 it's 16. We know how this works. As x gets bigger, the function f of x also gets bigger. Okay, goes all the way to infinity, right? As x goes to infinity, x moves along here up to infinity. This is infinity's direction. Then the function goes up to infinity, all right? And that's just one end behavior or one long run behavior. That's going every spot into the future. We also go all the way back into the past. So if we go back into the past, so we want x to go to minus infinity, and we write the arrows this way, but we're thinking x is going to minus infinity. It's getting smaller and smaller and smaller, right? Well, it's still being squared, right? So as x going to minus infinity, the function is still going up, right? The function is still getting bigger and bigger and bigger. F of x goes to positive infinity. So no matter what happens, if you let x get really big to infinity, or x get really small to minus infinity, the function gets as big as you need it to get to infinity. And that's called end behavior. To contrast that, let's look what happens to x squared. Pause the video for just a second and see if you can figure out what would happen to x squared as x goes to minus infinity or as x goes to positive infinity. What happens to the function? Oh, that was supposed to be minus infinity. All right, I hope you're back. As x goes, let's switch colors here. As x goes to negative infinity, x goes this way, right? That's negative infinity. X goes to negative infinity. The function goes to minus infinity. Minus x squared goes to minus infinity. And as x goes to positive infinity, moves along the x-axis this way, well, the function still goes down to negative infinity. So this is what happens in the end, in the long run, right? X squared, no matter if you go to positive infinity or negative infinity, as x goes big, f of x gets big. No matter which way you go with minus x squared, as x gets really big or really small, f of x gets really small. All right, so let's talk about another couple of functions. Keep that in your back pocket. Get the pictures in your head. Let's talk about x cubed and minus x cubed. All right, so on the left here in blue is f of x equals x cubed. I do not want my email popping up. Yeah, that's great. Thank you. All right, so let's look at the end behavior of f of x equals x cubed. X is going to go to positive infinity, right? That's what it means. X goes this way. What happens to the function? It goes up. So that means as x goes to infinity, this function x cubed goes to infinity. All right, what happens as x goes to minus infinity? As x goes to minus infinity, this way, right? The function goes down. So this one's different. The end behavior isn't the same. And this one is x goes to infinity, f of x goes to infinity. And as x goes to minus infinity, f of x goes to minus infinity. So that's how x cubed behaves. And you can see the shape of the graph, hopefully in your head. Here we are shooting off to negative infinity as x gets really small, and here we are shooting up to infinity as x gets large. All right, pause the video, and using the notation that I used, write down the end behavior for f of x equals minus x cubed. All right, let's check it out. So what happens as x goes to infinity for minus x cubed? As x goes to infinity, x is going this way, what's happening to the function? Minus infinity. And as x goes to minus infinity this way, f of x goes to positive infinity, right? So as x goes to minus infinity, the function shoots up. As x goes to positive infinity, the function shoots down. All right, so those are just a quick review of those toolbox functions and some introduction to some notation. So that's enough for the first video. This is really important concept, so I hope these make sense to you, and go ahead and start the next video when you're ready.